Which pipe consists of number of pipes which are attached between the tank to make the fluid flow from one pipe to other pipe that are bunched together. It can be one pipe connected between two tanks or the number of pipes attached to the number of tanks. This is a diagram of sketches the pipe flow rate.
See Weisbach equations and Picard equation which relates to head loss for a given length of a pipe to average velocity of fluid for a fluid. The- So the formula is H equal to F L V square over D over 2G. And you also write as H equal to R Q square, which is Q is flow rate and R is equal to 8 over 8 FL over D power 5 pi square G. Laminar flows occurs at low Reynolds numbers while viscous force are dominant and is characterized by smooth, constant fluid motion. Turbulent flow occurs at high Reynolds numbers and is dominated by inertial forces which tend to produce chaotic eddies, vortices, and other flow instabilities. Reynolds number is defined as RPR over epsilon over D is equal to epsilon over D. Can be defined also if fluid is in relative motion with the surface. Fluid flow is generally chaotic and very small changes to shape and surface roughness of bounding surface can result in different flows. Nevertheless, Reynolds numbers are a very important guide and widely used. Volumetric flow rate can be defined by Q equal to VA where V is flow velocity and A is cross-sectional vector area or surface. Okay.
Okay, for detailed specification, we use galvanized iron pipe with diameter of 10 centimeter or 0.1 meter with thread for assembly of the whole system. And then we use galvanized iron tip with slightly bigger diameter, it's just at two junctions. Then we use 45 degree of galvanized iron elbow. We use seven use and then length of the system. Tank to flush 10 10.4 meter and then tank to shower 10.53 meter, tank to tap 12.61 meter.
We have the Q total given is 5.5 meter cube per hour. So we find the area first is pi d square over 4 and we get the area is 7.85 times 10 negative 3 meter square. Then velocity formula of V equal to Q over A flow rate over area. So for V shower we get 146.5 meter cube per hour. V sink 127.4 and V flush tank we got 433.12. RPR is equal to epsilon over D. 0.15 over 100 is 1.5 times 10 negative 3. Then we got Reynolds number equal to density for V over D or 3 times D over U. Then 1000. So we got RE shower by 1.84 times 10 power 7. RE sink 1.6 times 10 power 7. RE flush tank 5.43 times power 7. For body diagram, we got 0.2 friction factor. Calculation on head loss. So we got HL measure FLQ square over 10 D5 D power 5. So we got HL measure by the 3988.7. HL minor KV square over 2G. HL minor we got by 3992.272.72. So H total is equal to 7981.42. Find back the formula using HL measure, we got 1.63 meter cube per hour. Using the formula for the shower head loss, so we can calculate the sink head loss as well by HL major FLQ square over 10d5 power 5. So you got HL major by 31016. HL minor is also the same by 1075.43. So yeah, H total is H major plus H minor. We got 4091.43. Use back the formula for HL major, we can get the by 1.163 meter cube per hour. Using the same formula as well for flush tank, HL measure is 3484 is 64.96 and HL minor is 12429.71. So the H total is 47294.7. Using the HL manager formula, we got 3.94 meter cube per hour for Q. So total up of all Q is Q1 plus Q2 plus Q3. You got 6.73 meter cube per hour. So that's the total Q.
For calculation, pipe diameter for 0.2 meter, like calculation pipe diameter 0.1 meter. From the calculation above, we determine that 0.1 meter pipe is much suitable than 0.2 diameter. Due that the total flow rate of the pipe from using 0.1 diameter pipe is much close to the theoretical value of the flow rate.
Okay, this is design costing. Line of pipe, we got 11.60 cm equal to 15.08 meter. We estimate 1 cm equal to 1 ringgit. So we got 50 ringgit point 08. Total cost for 3 type of piping was 38 ringgit point 08.
Design evaluation. Firstly, about costing. Low initial costing. GI process costs less because requires less manual labor. Secondly, about expired date. It have a long life, can last more than 50 years in many rural areas and 35 years in very exposed urban. Thirdly, the strength, toughness, have unique metallurgical composition that make it rugged and it can resist damage. Fourthly, maintenance costs. Have low maintenance costs, it was ruggedness and long life that have less effort is needed to maintain the steel. Fifth is standardization. This product meets the standard that can be able to accurately predict the lifespan and performance of the GI pipes. Six is protection. Have an automated protection. Galvanized coating offer cathodic or sacrificial protection that protects small areas of the structure that have been exposed to the damage.
Based on the proposal, we know how to determine the required pumping system for the second floor on the double story house. Consider all friction loss. Besides that, we have been explored on about the material we chose in this project, which is a definite iron pipe with diameter 0.1 meter. Finally, we have know how to prepare the purpose according to the real situation.